Question 13 was quite a tricky little question. We don't have a power here, so we can't actually do the NCR trick on the calculator because we don't actually know what n is for this case. But we can actually start to set out the question now. We can certainly say it's NC0, NC1, NC2. And first term to the power of n, then decrease the power by 1, decrease the power by 2. And the last term to the power of 0, increase, increase. Now, the first number in Pascal's triangle we always know is going to be 1 anyway. And the second number from Pascal's triangle we also know is always going to be the number itself. So we can say that that's n. The one that would be a little difficult to figure out is n minus 1 over 2. And we actually get that by using the rule for factorials. So you might want to look up that in the chapter, or you might just want to remember that NC2 is n minus 1 over 2. Now looking for us, this does start with 1, so 1 to any power is just quite simply 1, which makes those terms actually disappear. So what we actually end up with is this. Now it tells us in the question though that this is the same as this. So what we can do here is compare the coefficients of x, and we can compare the coefficients of x squared. If these two sequences are indeed alike, then the coefficients must be exactly the same. So what we end up with is a system of equations. We have two equations, and both of them are in terms of a and n. So we need to solve this. Now the easiest one to rearrange is this one. I'm going to solve it for a, because a only appears once in this formula, where n appears twice. So to solve for a, 36 divided by n, and then I can substitute this into this equation. Oops. Better. So this was the formula, and then where it says a, I'm just now going to simplify in what I just saw, 36 over n. I can also expand this out, or I can also get into my fraction here by times it by 2. I got a couple of options. I actually left it for this one. So I distributed 36 squared is 1296, and then n squared times by 2 is 2n squared. I then simplified the 1296 divided by 2 to get 648, and I also simplified the n with the n squared by cancelling an n from here and an n from here. I get left with n on the bottom. And then now I can also multiply both sides by n to get rid of this fraction. If I go ahead and then distribute and then collect like terms, I should end up with a linear equation which I can actually solve. Oops. And once I've solved for n, if I plug this back into the original equation, 36 divided by n will give me the value for a as 4. So quite a complicated system of equations, probably certainly anything longer than we've encountered before, but gives you some idea of the rigour that they would expect in the ACE class.